Alright guys, in this video we're going to review quadratics a little bit more. We started last class, and so now we're going to review finding roots. And just specifically, we want to look at what are roots? Well, roots are really just x-intercepts. We want to find where these quadratics are going to cross over the x-axis. So if our quadratic looks like this, our roots are right here and right here. Our quadratic looks a little bit different, you're going to have some different roots. So based on whatever quadratic you have, we want to find where it crosses over the x-axis, at what points it crosses the x-axis. And specifically in this video, we want to look at how can we do this by factoring. How can we factor these quadratics and figure out where they cross in order to figure out where they cross over the x-axis. Let's go ahead and get into it. There's a series of steps that we have to do in order to do this. Step one is to make sure that it's set equal to 0, or in other words, everything is on one side. So if you look at this first example here, we see it's already set equal to 0. Every term that's non-zero is on one side and it's set equal to 0. This one over here is a little bit different. It's not set equal to 0. So we need to make sure that everything is on one side, and we'll do that by subtracting 8x to the other side. So I have something that looks like 2x squared minus 8x equals 0, and I've got this particular thing going on, so I can move forward. So after we have everything set equal to 0, you notice I adjusted it so that it reflects what we did in the last step. So the next thing we're going to look for is there a greatest common factor? So we're going to look at each one of these individual terms. We're going to list out what we call a prime factorization for each term. And we're going to see if they all three in this case have something in common. We see we've got an x and an x in common in this one, but there's no x in the third term, so that's not a greatest common factor. And in fact, this first one, no greatest common factor. So we can't really do anything with this one in regards to greatest common factor. This other one over here, we've got a 2 and an x as the prime factorization for the first one, a -1 and a 2, and technically 2 2's, or just 2 times 4, however you want to write that. And we can see we can pull some stuff out of this. Each one of these has a 2 and an x in common, so we can take the 2x out front, and whatever's left, whatever we didn't take out, stays on the inside. So that's x minus 2 times 2 is 4 on the inside, and we took out a greatest common factor for this particular quadratic. So let's move on to step 3. After you set it equal to 0 and find the greatest common factor, now we want to factor it. You can see that I've adjusted these equations based on taking out that greatest common factor and setting it equal to 0. So now we want to factor. This one didn't have a greatest common factor, so the factored form is going to look something like some binomial, or something with 2 terms, times another thing with 2 terms in it. And so when we go to factor this, we're going to factor this by looking at first the factors of x squared. So what times what equals x squared? Well, I know that x times x equals x squared. Second thing is we want factors of 2, and the only factors of 2 are 1 and 2. So I need a 1 and a 2. And then the last thing is I need 2 things that multiply to 2 but add to -3. So I need to adjust my signs accordingly. Things that multiply to a positive 2 are either plus plus or minus minus, but they also need to add to a negative. So the only way that that happens is if I have 2 negatives, and we can check this factored form by checking the inside, gives me a -1x, and the outer 2 terms gives me a -2x, which gives me a total of my middle term. So we have that factored form. Over here, we took out a greatest common factor. We can't break these individual terms down any farther, so it's already factored based on the greatest common factor. All right, so we've got it set equal to 0. We pulled out any greatest common factors. We factored it. And now we just want to use this zero product property, what we call the zero product property. And all it says is if I take two things and I'm multiplying them and they're equal to 0, then I can split it up. So either the first one is 0 or the second one is 0. So that's all we're going to do. We're going to split these factors up. We know that either this one has to be 0 or this one has to be 0. And then we can solve it. So I've got x minus 3 equals 0. So I can say, hey, x has got to be 3 or x is equal to 1. And these are the roots of this particular quadratic, 3 and 1. Moving over here to the second example, I've got 2x times an x minus 4, and we're going to take the same approach. We're going to say either the 2x has to be 0 or the x minus 4 is 0. And we can solve it from there. We would divide by 2, and 0 divided by 2 is going to be 0. So either x is 0 or x is positive 4, and those are my roots for this quadratic, for example 2. So just to review this process, the first thing that we need to do is get everything onto one side or set it equal to 0. The second thing is see if there's a greatest common factor that we can pull out front like there was in this one. The third step is to factor it. This one's already factored based on the greatest common factor. This one, we needed to break this trinomial with 3 terms into some quantity times some quantity, or in other words, kind of like a FOIL type problem. And then the last thing is split them up. Split them up. So each one of these terms, if when they're multiplied they're equal to 0, we can say that one or the other has to be 0 and solve accordingly. So at this time, you guys can, on your worksheet, go ahead and complete the rest of those problems in the front side there. And I'm going to go ahead and move on to the next set of notes we want to review. The next part of this, in finding roots, there are 2 different ways that we can find roots. The first is by factoring. The second is by using the quadratic formula. So down here you see the quadratic formula. And it's important to note that where we get the a, b, and c. So the first thing is a is always the number in front of the x squared term. B is always the number in front of the x term, and c is always the number that's by itself. So that's where we get these things. And once you have those numbers, you can just plug them into this formula and go through and solve. So let's look at a couple examples here. First example, again, we're finding roots. This is what we're doing. We're finding where it crosses the x-axis. So let's go ahead and look at this. The first thing that you notice is that everything is not on one side, so we have to make it that way. And in order to do that, I need to add 2 to both sides. So I've got x squared minus 3x plus 2 equals 0. And then from here, I can identify my a, b, and c. Remember, a is always the number in front of the x squared term. So for us, that's a 1 in this particular case. B is always the number in front of just a single x term. So it's a negative 3. You take the sign with it. And then C is always the number that's by itself with a constant term. So we know our A, B, and C, and we can go ahead and plug it into the formula and find our root. So let's find our roots. We can find our roots using quadratic formula here. Negative b, remember you got to take the b and make it opposite. So negative 3 turns into a positive 3, plus or minus the square root of b squared, that's negative 3 times negative 3, that's 9, minus 4 times a times whatever c is. A is 1, c is 2. Over 2 times whatever a is, so that's over 2 times 1. So the first thing we're going to do is simplify some stuff. We're going to work inside the square root first. So we've got 3 plus or minus. Inside the square root, it looks like 9 minus 4 times 1 times 2 is 8. So 9 minus 8 is the square root of 1, which is just 1, over 2 times 1, which is 2. Simplify a little bit further. 3 plus or minus the square root of 1 means that the first thing we're going to do is we're going to add 1. And then the second thing we're going to do is subtract 1 from 3. So 3 plus 1 over 2 and 3 minus 1 over 2 are going to give me my two roots. Go through and simplify. Remember, we're going to do the top. Simplify the top completely and then divide. So x equals 3 plus 1 is 4. Divided by 2 gives me 2. There's one of my roots. My other root is going to be 3 minus 1. That's 2. Divided by 2 is going to give me 1. So here are my two roots, and that means on this graph, whatever this quadratic looks like, my x is going to cross at 2. So there's one of the roots. My other root is going to cross at 1. So my quadratic, it opens upward based on this number, is going to look something like this. One more example, a little bit different type of example here. Same process though. So the first thing is we need it set equal to 0. So that's good. We've got it set equal to 0 already. So the next thing is if we're going to use the quadratic formula, we want to figure out what our a and our b and our c is. So in this case, a is the number in front of x squared. So a is 1 in this case. B is the number in front of the x term. And you notice we don't have an x term. So technically this is plus 0x. That's in here. We usually don't write the plus 0. So b in this particular case is actually 0. And then c is a number that's by itself with a constant term, so that's negative 4. We've got our a, b, and c. Let's go plug it into the quadratic formula. So quadratic formula tells us that we can find our roots using x equals negative b. Well, technically that's a negative 0 plus or minus the square root of b squared. So again, 0 squared is just 0 minus 4 times a, which is 1, times c, make sure you take the sign with it, over 2 times a, or 2 times 1. Go through and simplify. When you simplify, we're going to work in the square root first. So negative 0, we don't need to write that. Keep that plus or minus in there. Plus or minus the square root of 4 times 1 times 4 is 16. Notice there's a negative 4 and a negative 4, so it's actually positive 16. So it's plus or minus the square root of 16 over 2. Simplify a little bit further. We know the square root is 4 of 16 is 4. So it's plus or minus 4 over 2. And here again, we're going to split this up into plus 4 over 2, where x is negative 4 over 2. One last step to simplify. I've got one root at 4 divided by 2, which is 2, and another root at negative 4 divided by 2, which is negative 2. So here are my two roots. If I go over to my graph, there's one. There's the other. That's where it's going to cross over the x-axis. We know, again, that this opens up because our a term is positive. So our quadratic here is going to look something like this. And that's it.